You happy to kick off?
Sure, I'll give it a go. Pun was not intended, I'm sorry. Anyway, well, thank you all for having me. My name is Grayson, and the title of this talk is Do It Yourself Gosec, Detecting Complex Code Patterns Using Semantic Grep. So the slides for this will be posted somewhere at some time. We're doing some transition on where we post our slides, so I'm not sure where that'll be just yet, but we'll I'll notify you guys when that gets decided. Anyway, so the too long didn't watch of this talk is that writing secure code is hard, and current static analysis tools are too noisy and too slow. Grep itself is great, but it's not really expressive enough for matching what you want to match. And so we need something that's fast, code-aware, flexible, powerful, and open source, which is Semgrep. Semgrep is a fast and syntax-aware semantic code pattern search for many languages, which is a mouthful. So a quicker way to remember it is it's like grep, but specifically for code. So you can use Semgrep for a lot of different things. These are kind of the primary use cases: searching code, finding security bugs, for guarding your code. If you integrate it into continuous integration environments, you can enforce specific patterns and best practices. You can also use it to migrate off of old or deprecated APIs, etc. Semgrep makes it really easy to do that. But first, a little bit about me. I'm Grayson Hardaway. I'm a security researcher at R2C. And this is a picture of me and my lovely new bride. In a past life, I used to work for the US Department of Defense doing all manner of things. But now I work for R2C, and I've been here for about a year. So we are based in San Francisco, and we're a static analysis startup on a mission to profoundly improve software security and reliability. So this is a picture of the team down here. And so I wanted to take a second to recognize that all of the work that you see here, the technology and the concepts, the ideas, none of it would be possible without the team. And so they are an incredible group of people to work with, highly intelligent, highly motivated, and also like really humble people. So it's just a great team all around, and I want to give them a special shout out. So a quick outline of the talk is here. I'll go over a little bit the background of the tool, talk about grep and code for a little bit, and then just show you a bunch of examples. Talk a little bit about integration into continuous integration environments, and talk about our Semgrep rules registry. So as I mentioned, Semgrep is open source. You can go check out the code on GitHub, and you can fork it, and you can try to read it if you want. The core of Semgrep is written in OCaml, which I have not been able to decipher myself. So, you know, it's a fun day at the office when I'm bug fixing in OCaml land. But Semgrep itself actually has a long history of being open source. It originated at Facebook over 10 years ago, actually, and was used there to as part of their early static analysis program, enforcing nearly 1,000 rules. So the original author, Johan, who's pictured here, joined R2C last year, and he was the first static analysis hire at Facebook, has a PhD from INRIA, and was a contributor to Coccinelle, which is sort of the predecessor to Semgrep, but specifically for C. And so Semgrep itself now supports a lot of different languages, including C, also Go, and a handful of other languages that you can see here. And we're constantly adding new languages, and we're constantly looking for, soliciting feedback for which languages are popular and people would be really interested in. And so we just shipped a alpha for Ruby to select members, and we're currently working on getting TypeScript support ready to go. So that's a little bit about the background of Semgrep. Now I want to talk a little bit about grep and using that for like matching code. So imagine a situation where you have a code base and you want to find a particular snippet of code. You might return to regular expressions, which totally makes sense. Regexes are great for rapidly searching for simple text and patterns. But if you use regexes for code, you can quickly find that it's a little bit of a headache. And this is the classic XKCD of using regular expressions to try to solve a problem, and then it becomes one of your problems. Using regular expressions for code detects extra things, like you might find code that's in comments. You might find it if it's in a documentation or in a string literal or something like that. And it also misses things because our grep patterns, like we frequently don't think about like white spaces or new lines, and so we end up missing a lot of things. And the reason for that is because code fundamentally really isn't a string, it's a tree. And so if you remember way back to your compilers or programming languages class, code gets parsed into an abstract syntax tree or an AST. And it's that representation that really makes it easier to be precise about your code searches. And so there are all manner of AST matching tools, to include Gosec, which is in the title of the talk. There's also others for other languages, like ESLint for JavaScript, Flake8 for Python. But some problems with that, with the AST matching approach, is that if you're trying to match code using AST matchers, you have to become an expert in the AST syntax for every language that your team uses. So if you're on a team, you've got multiple languages, you gotta learn all of these different things. Another barrier to entry is that if you're writing an AST matcher, you now have to think about your code in terms of a tree, which isn't always intuitive. Like we don't really think in terms of a tree when we're writing code. So it ends up being complicated to learn how to write a matcher. And so there are commercial static analysis tools, but these tend to be cumbersome. They're not easy to extend. They have like complicated domain-specific languages, or they don't integrate very well with other tools. They're also very slow. They tend to take hours to run on large code bases. And of course, because they're commercial, they cost a little bit of money, or a lot of bit of money, depending on who you are. And so to sort of like meld the two worlds between grep and these tree matchers, Instagram rather, published this really insightful article last year about static analysis. And it featured this really apt chart. On the left, you have regular expressions, which are easy, but they're limited. And on the right side, you have whole program analysis, which is powerful but complex. It's often difficult to customize and is often very time consuming. And so Semgrep sits somewhere in the middle, where it provides an easy interface, but works on the tree representation of the code. Semgrep also operates specifically on files, so it doesn't do whole program analysis, which means we lose a little bit of fidelity, but what we gain is speed because we're not trying to do everything. And so the key insight for Semgrep is this, is that Semgrep lets you reason about your analysis the way that you reason about your code. So it's not complicated, the barrier to entry is low, but it's much more precise than regular grep. And so without further ado, I'm just gonna jump into some examples here. So I'll start with a quick overview of core Semgrep concepts, and then go into some other uses, and then some advanced features. So let's say that you're working for a company and they have outright decided to ban RC4. RC4 is known to be a poor cryptographic operation, and so your company has just decided we're never going to use it in our code anymore. And so Semgrep can help match that using something called the ellipsis operator, which helps abstract things away. So I'm going to click on this link, and I'm going to look over here, make sure. Could you guys give me a thumbs up, make sure that you can see the window as I change? Sweet. And so this is our live editor that where you can just play with Semgrep in sort of a sandbox format. And so this bottom pane here features code that you want to match. So you can see these examples here from the slides. And then this top pane here is where you would write your Semgrep pattern and some other things in here, but the pattern is all that we're going to worry about. So the easiest way to work with this usually is to just copy some bit of code that you're looking for and paste it in directly and run it and see what you get. And so right away, we get both of these hits, which is really nice because you can see that Semgrep has an advantage over normal grep, because if you didn't account for white space in your grep pattern, then you wouldn't catch this one. But we also want to catch this one here. We want to catch all calls to rc4.newCipher. And so we can do that with the ellipsis operator, which works a little bit like .star and regex. And so we just say ... which means I don't care what's in here. And if we run it, we'll be able to detect all three of these. And so the next example is, let's say you want to detect any function that comes off of the unsafe package. So similarly, we can start just by copying some code up here and seeing what it matches. And what we'll get is the exact match where unsafe.pointer is called with int pointer. So we can do the same thing as last time, where we add an ellipsis to make sure that we get all calls to unsafe.pointer. So now we get this one, but we also want to get this unsafe.sizeOf. And so I'm going to introduce a new thing here called a meta variable, which basically says, I know something in the code belongs here, but I don't know exactly what it is. And so meta variables in Semgrep start with a $, and then are all caps characters like this. And basically what this says is, I know something goes here, but I don't know what it is. And if we do this, we'll be able to detect all methods that are coming off of the unsafe package with any parameters. Next example is finding insecure SSL configurations. And so this one in particular uses an old deprecated version of SSL, and then sets this insecure skip verify to true, which can be an insecure setting. And so if we jump over to the live editor real quick, you can see that this pane looks a little bit different. And that's because there are two tabs up here. One is the simple editor, and one is the full or advanced editor. So behind the scenes, Semgrep rules are really just YAML files that have a bunch of like information and data in it. And then the Semgrep rules are a bunch of these patterns that are composed together. And so this is the, what I want to highlight here is that you can do logic on pattern matches. And so it doesn't just have to be a single pattern. You can actually say like, it has to be this and this. Or in this case, what we're going to do is we're going to look for situations where the tls.Config has an insecure version and where insecure skip verify is true. And so we'll fill in this here with insecure skip verify is true. Oops. Now we should catch both of these if I typed correctly, and I did, yay. Cool. So these are kind of the basic building blocks of Semgrep: ellipsis, meta variables, and then pattern composition. But combined together, it creates for a really powerful expression language that allows you to search code with precision and speed. So if those pattern clauses were confusing, we have documentation. You can check it out on our GitHub. And so it will detail to you how all of the pattern clauses work. And you can think of them primarily as like set operations, or more loosely, you can think of them as Boolean logic. There are a bunch more pattern clauses that we feature in here, and I'll go over a couple of them a little bit later. So moving on to some other uses. The examples that I gave are all like security based, but you can use it for other things too, such as detecting anti-patterns, or if your organization has like coding standards, you can write a bunch of Semgrep rules to enforce those. And so some people consider this to be a Go anti-pattern, where you define a function where the only thing that function does is call a Go routine like this. And the reason it's considered by some to be an anti-pattern is that it's not clear when you call this cleanup function that you're actually spinning off a Go routine. And so the preferred method of doing this is to be explicit. Just define your function like normal, and then explicitly call that function. And so if we jump over to the editor, you can see that we can detect that no problem. So this function only defines anonymous function with Go, or calling Go on it. This one does some other stuff. This one does some other stuff, which is perfectly fine because that's expected. let's say you work for like a financial organization or something like that, and you've inherited like a very old style API. And so in this case, what you want to do is, what this API requires of you is that you call verify transaction before you make transaction, call make transaction. So you want to make sure that your transactions are verified. And so this Semgrep rule basically says you must call verify transaction before you call make transaction. And it's already run for me down here, which means we can check out the examples. So you can see here, it didn't fire where verify transaction was called before make transaction, which is good. This transaction is not verified, which is bad. This one is verified after it was made, which is also bad. And then you can also like intersperse some code in here. The ellipsis operator, as I mentioned earlier, abstracts away sequences of things, which can also be statements. So you can add them kind of like hanging loose like this, and it'll say, you know, basically like, I don't care how much code is between here and there, for instance. Now, one thing that I want to highlight down here in this example is that this did not match because verify transaction is called before make transaction. But the problem with this one is that it's verifying the wrong transaction. And so what I want to highlight here is that Semgrep is actually smart enough to detect when the meta variables are the same in the code itself. And so if I change this to be the same meta variable, what we're saying now with this pattern not clause is that we're going to filter out these cases. So basically, we're going to, previously it was filtering out any situation where verify transaction was called before make transaction. But this one, that's true, but it was on the wrong transactions. And so now it's forcing them to be the same. And so if we run that, we'll see that we'll detect it, which is super cool. So these meta variables, like Semgrep is smart enough to know that the meta variables are the same. Moving on quickly, some sort of more interesting applications of Semgrep rules or patterns is that you can interpolate your meta variables into your message if you want to do that. And so this will extract all the routes in your Gorilla Toolkit application, for example. So you can see that like route handler and HTTP verb are all over here. You just spit out a message, which means every time you get a match, you get a nice comma separated value of those things. And so this ends up being really cool for building out like a profile of your application. And so this is a visualization that one of my colleagues put together that extracted all the routes in, I think it was a Flask application, along with authentication information. And so the colored circles represent the authentication information available in that route. So green is like admin routes, yellow is you need a JWT token to access it, and red is there's no authentication required. And so this ends up, we've used this, actually, this visualization in security audits when we've gone into code bases and been like, we want to find all the routes, because it helps us figure out where to start, because we want to check out the unauthenticated routes first. Semgrep has limited support for autofixes, which is where it's useful for upgrading off of deprecated APIs, for instance. And so there's a couple of different ways in which Semgrep supports autofix, which are all in documentation. But the one that I'm going to demonstrate here is does regular expression replacement, which doesn't sound all that awesome, except it ends up being really powerful when you combine it with the pattern matching capabilities that are inside Semgrep. And so the regular expression replacement will only apply inside the match, which means if you are confident in the match, then you can be confident in the replacement. And so this is the insecure TLS configuration from earlier. And all we want to do is upgrade the TLS version from SSL 3.0 to TLS 1.3. And so this fix-regex key will do that for you, where you specify the regex that you want to match and the replacement that you want to replace it with. And so in the live editor, if you do this, it'll give you a nice little preview of what it'll look like over here. You can check it out and be like, yep, that looks good. And then if you apply the fix, it'll just apply it in line. Semgrep is also scriptable. And so if you find that you're not quite able to match what you want, you can always just apply apply Python to it, because that's the only one we support at the moment. with this pattern where Python clause. And so that'll take a Python expression that evaluates to true or false, and Semgrep will only report the match if the expression evaluates to true. And so this example checks to see if this $F is price. And so it's it's detecting if a float is being used for money transactions, which could be subject to routing errors, which is bad. Because this ends up reaching out directly to an interpreter, like the Python interpreter, you have to use this dangerously allow arbitrary code execution from rules flag, which is very explicit, which means you know exactly what you're getting into, which means we're trying to be very clear about what's happening so that you're not surprised if you accidentally allow yourself to be injected or something like that. And so one of the best use cases for that is in just doing operations on numbers. And so RSA keys are generally considered to be secure if you use 2048 keys or more. And so this pattern where Python clause takes this bits meta variable and only reports a finding if it's less than 248, which is cool, which is this one right here. So that's a very quick overview of what you can do with Semgrep. There's obviously many, many more things you can do. But what I want to talk a little bit about now is guarding your code with continuous integration. So Semgrep is super easy to work with. So we use the word grep intentionally because it's supposed to feel like grep when you're using it on the command line. And so it's easy. That makes it easy to integrate into any system you want. If you want to run it manually, if you want to integrate it into some system that we haven't yet, then you can do that. We have installation instructions for GitHub Actions, for regular pre-commit hooks, GitLab, Circle CI, and all the other ones that you see here. And because Semgrep can output as JSON, it becomes very easy to consume with any other system that you want. And so I don't know how clear this is. I meant to actually make this bigger before the presentation and I forgot, I'm sorry. But this is Semgrep running as a GitHub action on one of our repositories, which is a Flask application. And down here, it detected path traversal in our application before it went out into production, which was very good for us because we don't want that. So yeah, it's super cool. The last thing I want to talk about is our public registry. So if you're like, cool, this is awesome, but I don't want to write all these rules, then maybe we've written them for you already, or someone has. And so we have a community rule registry with, I think it's like over 400 rules at this point. Some of them developed by us, some of them developed by community contributors. Of note, there's the guy who maintains Node.js Scan, which is a Node.js security scanner, is entirely powered by Semgrep now. We've ported over some of the Gosec checks. So if you want to try that out, you can do that. We have rule ideas contributed by prominent people like the Django co-creator and the people who maintain Flask currently in Python. And then we have independent security researchers as well who contribute rules. So they go like find super cool bugs and then write rules for us, which is pretty neat. So consuming rules from the registry is really, really easy. All you do is install Semgrep, and then you point it at a URL, and you get those rules. And so as an example, if you wanted to run the selected rules from Gosec that we have, all you have to do is point it at this URL, the Gosec pack of rules. So we like grouped them into packs as well. So what's coming up next? We're working on more code equivalences. So just because we support the language doesn't necessarily mean we support what the developer expects that language to do. And so some things that like would be considered equivalent, we're working on integrating more of those. We're working on better type inferencing, particularly in Go, constant propagation via data flow. We're working on, within the same file, a tainting engine as well, taint analysis engine. And then obviously more languages. So we have a Ruby alpha and TypeScript coming. And we also have a cool feature in the works called pattern from code, where you can like highlight a code snippet and it'll suggest a pattern for you, just to make it really easy to get started. And so that's pretty much everything on my end. Semgrep is really easy to get started with. You can install it locally using brew or pip. or you can get it as a Docker container if you want. You can use the online editor if you don't want to install anything. And that's about it. So if you have time and are willing, please consider taking the survey at r2c.dev/survey. Your feedback is much desired because we want to know what people want to use this tool for, and like your feedback will help us kind of decide which direction to take it in next. So please and thank you.
That's great. Thanks very much. Sorry, there's no clapping or anything. We could do
it's all good.
language style. But we do have a couple of questions in the chat. So if you've got the chat, you can go there. Someone's asked if the patterns are applied in any order. So when you have your patterns.
Yes, and it primarily depends on the pattern composition. And so by default, all patterns are implicitly ANDed together unless you specifically tell them not to. And so underneath the hood for pattern composition, it's basically like set operations, which means, you know, it sort of collects all of the pattern matches and then, you know, does intersections, unions, and subtractions on the sets depending on which pattern clause you use. I don't know if that correctly answered your question, but
Leon, did that address the question? Yep.
Awesome, thanks.
Oh, cool. Are you catching up? So Jonathan asked a couple of questions and Adam's just writing something in there as well. So Jonathan's questions, can you see the questions, Grayson?
Yes, I can now. So it looks, if I'm at the right point, it says, can you verify that two calls happen within the same scope? For example, one is not wrapped within an if statement, so may not be executed in all cases. So the answer to that is maybe, and the reason for that is because we've been messing around and experimenting with basically like flattening everything inside of a function scope. And what we've learned is that it works well for some languages and not for others, essentially. So one language that we support, for instance, is JavaScript. And one problem that we run into with JavaScript is minify JavaScript, which we run into quite a bit. And so flattening there kind of helps us out a little bit, but it hurts us in other circumstances. And so I don't actually know where we landed with flattening in Go. And so I wish that I had a better answer to your question for that. But if you use it and you find that it's not to your liking, you can make a ticket and we will fix it. So yeah, if you're interested, like we need the feedback of Go developers because Go is not a strong language in R2C. I see the next question is, has Semgrep been applied to secure code training tools? I would ask for clarification on what you mean by secure code training tools.
Jonathan's still got mute on, so.
Oh, can you hear me?
Yeah.
Yes, I can.
Yeah. I was just gonna ask if you have like created any tools where people can like try and write the secure code and it kind of highlights if it's matched or not matched to secure regexes or yeah.
So it sounds like maybe what you're talking about is like some known vulnerable tool, like repositories.
Like you might have like a test to write secure SSL TLS code, and then it like highlights it green once you get it right, or if you get like the version wrong, it makes it red.
Oh, gotcha. We haven't done that. We have a couple of like severity levels that you can add to Semgrep, which means it's totally doable. So once upon a time, I don't know if this is still true, but we used to support like the okay severity level. And so you could, you know, feasibly write one pattern that is like report a warning, and then you could write another pattern that's like, this is okay. And so, you know, the actual application of the match is kind of up to the user. So you can imagine a situation where you're actually looking for the correct application of these things versus the incorrect application, but like we may not know what that is, the user would, and so we,
Yeah.
The next question I have from, oh, sorry, I didn't.
Yeah, the next question's from Adam. Is that what you're looking at? Oh, cool.
Yeah, the next question I have from Adam Scar is, with the verify make transaction example, how smart are meta variables? Will they detect two different variables with the same names from different blocks or scopes correctly? Yes, and that's how it's supposed to work anyway. So if it doesn't work that way, let us know. Will it detect if one side of that is wrapped in a subcall? As written, it probably wouldn't. However, there's a feature in Semgrep called the deep expression operator, which is it's basically like a really big ellipsis. And so what that says is, that would find it if it was in a subcall or any form of sub-expression. And the next question from Darren reading is, does the size of the code base or number of the rules affect performance? I mean, the answer is yes. We work pretty hard to keep it really snappy. And in fact, what I did, I was actually on vacation last week, but the week before that, what I did was work on a bunch of benchmarking for our rules. And so one of the repositories we tested our Go rules against was Kubernetes. And we found that a couple of our rules like really ground everything to a halt. So we just booted them until we could fix them. So if you end up running Go rules, like you won't get those because they're really slow, but all the rest of them you're going to get really fast. So.
Okay, I think that's it then for the questions. So thanks very much, Grayson. That was great.
Cool. Thanks, everybody.
And people can follow up. They've got the survey and other things. So I think it started people thinking. So it's really good.
Absolutely. Thanks, everyone.